Welcome back everyone, Patrick here. Moving on to the next video dealing with completing the square. What we got to do is we have to find the max or min point of these quadratics here by completing the square, and then we also have to sketch the graph. So if you remember in the previous video, we dealt with quadratics where that a value was 1. And so completing the square was a little bit easier than it's going to be in this video, because in this case the a value is not 1 in all of these. So there's going to be some preliminary steps in terms of first factoring out that a value from the first two terms and then going into the completing the square process. Now, when they're asking for a max or min point, they're basically asking for the vertex. Now, depending on your teacher, depending on the textbook, the max or min point can be the entire vertex. So what we're going to do is we're going to take these standard form quadratics and then convert it to vertex form. And so the max or min point can be the entire vertex, or it could just be the y value of the vertex. Some textbooks will say like a max value of a single number, or they'll say maybe like a max value of a coordinate, which is the vertex. And then whether it's a max or min, as we've done in previous sections, that depends if the quadratic is opening up or down. So if it's opening down, we're going to have a max point. If it's opening up, we're going to have a minimum point. And you can actually see just here in the standard form by looking at the a value. If it's negative, we know it's opening down. So this is opening down. So these two are going to have a maximum point. This quadratic here, the a value is positive, so we know it's opening up. So it's going to have a minimum point. Okay, so you could tell from here whether it's a max or min you're dealing with. You don't necessarily have to convert it to vertex form, but that rule of the a value either being positive or negative also applies in the vertex form. Right, so let's go here. Now, in the previous video, I mentioned how when a quadratic is in standard form, it's easy to get the y-intercept. It's always just going to be the c value, because if we write out this first quadratic, to get a y-intercept for any kind of graph, how do you do that? You plug in 0 for x. So notice when we plug in 0 for all these x values, we're going to end up with this being 0, this being 0, and then we'll end up with -3 right there, which is just the c value. So remember, for a standard form quadratic, the c value is always the y-intercept. So while we're at it, before getting the vertex, we might as well just write out the y-intercept to put a little bit more detail into the graph. So now let's get into finding the vertex. And so to do that, let's complete the square for this particular quadratic. So first thing we check, is the a value 1? Notice it's not 1, it's -1. So what we want to do, as we showed in the overview video, you want to take out the -1, not from the entire quadratic, but just from the first two terms. So if we take out a negative from these two terms, we'd end up with x squared minus 16x, and then we have the -3 at the end like that, right? So basically just the signs changed for these terms here. So then what we do is whatever quadratic we have left in this bracket, we take the b value divided by 2, and then we square it. So when we factor something out, we don't take this b value divided by 2 and square. We take the b value of the quadratic inside the bracket. I mentioned that in the overview video as well. Right? You have to make sure that that x squared is by itself, and so for that quadratic, we're taking this b value. When the a value is just 1, we didn't have to factor anything out in the previous video, so we were able to do the b over 2 squared for that value, but now it's going to be for this value. So that's going to be a big difference. So we would do -8 over here, do the bracket first, square that, that would give us positive 64. And so what we do then is we add 64, subtract 64 inside this bracket, and then we got the -3 at the end like that. Okay, so it's like we're adding 64, subtracting 64, so this is just 0. So this and this are the exact same thing. It's just we have more to work with now. And the reason why we want to do that is because now these first 3 terms here, they're going to be always a perfect square trinomial. But before factoring this, what we got to do, this is another unique thing when we have a factor outside here, is we got to take this negative value and bring it outside. But when we take it outside, we have to multiply it by whatever value is in front over here. So to rewrite this, we'll have plus 64 here, and then this negative 64 we are taking out, but we're multiplying it by this negative 1. So negative 1 times negative 64 would give us positive 64, and then we'd have a minus 3, like that. So don't forget this step over here by multiplying whatever value you're taking out right there. And so after that, what you want to do, let me actually write this term over here, just to give myself some room. So over here, 64 minus 3, that's just going to be positive 61. And then these 3 terms remaining in the bracket, when you factor them, that's always going to be a perfect square trinomial. And a shortcut you could do is just put x minus half of that value. So it's going to be 8, and then that's going to be squared. And then this sign and this sign are always going to be the same. Okay, if you take x minus 8 to the power 2, expand it, you'd end up with x squared minus 16x plus 64. This bracket's always going to factor into some bracket squared, like that. And so now, notice, we took this quadratic and changed it to vertex form. So this quadratic, they're the exact same thing. If you were to graph both of these on Desmos, they would be right on top of each other. They're the exact same graph. But what's nice, now that it's in this form, we can get the vertex. And so it's 8, remember it's the opposite sign there, and then positive 61. And because it's a negative a value, it means it's opening down, right? We could also see over here, it's opening down. So this here, it's going to be a maximum. And then let's put the actual coordinate. Okay, so again, depending on your teacher, depending on the textbook, they may just say a maximum of 61. Some of them will take just the y value of the vertex when they're asking for a maximum. Some will just say the entire vertex. For this video, I'll just put the entire vertex. Okay, and so from here, what we got to do is just graph this. So if we do a quick rough sketch, 861, so that's going to be like up here. And then we got 0, negative 3 for the y-intercept. That's like right over there. Now, you don't even have to worry about whether it's opening up or down when you're graphing it if you have the vertex and then the y-intercept, because you could tell just from connecting these points that it's going to open down, right? So the fact that the vertex is up here and then the y-intercept here, it's obvious that the parabola has to open down. So it's a nice way to sort of check whether this makes sense, the fact that it's opening down with this negative 1 as the a value, right? And then from here, from the graph, you could tell that you're dealing with a maximum point. So you don't necessarily have to look at the a value, but it's a nice way to check that everything is making sense. Right, so that is the graph right there, the rough graph. So let's move on to part B, negative x squared minus 10x plus 1. First thing we can get the y-intercept, so that's going to be at 0 and 1. Let's write that down. And then because it is a negative here, we know we're going to be dealing with some kind of max value. Let's find what that vertex would be. So what we would do is we're going to take this quadratic and we're going to complete the square on it. We're going to change it to vertex form. So take out the negative 1 from the first 2 terms. Then the plus 1 stays on the outside. And then we take this b value inside the bracket, which is positive 10 divided by 2, square it. So that would be 5 squared, which would give us 25. So then we'd end up with negative bracket x squared plus 10x plus 25 minus 25, and then we got a plus 1, like that. Then what we do, we take this negative 25, take it outside of the bracket. When we're taking it outside of the bracket, we got to multiply it by what's in front of the bracket. So negative 1 times negative 25 would give us positive 25. And then we still got that plus 1 right there. And then we'll have this is going to be a perfect square trinomial. That's going to factor into x plus 5 squared. And then we have 25 plus 1, which would give us 26. And so from here, we have that quadratic in vertex form now, right? This quadratic, they're the exact same thing. And from here, we could tell what's the vertex, negative 5, positive 26, and it is a max value. And so doing a rough sketch of that, we got negative 526, so that's like negative 5, let's say 26 is like up here. Right, so let's label this negative 526, and then we have a y-intercept at 0 and 1, that's like over there. So it's going to go through that y-intercept, and it's going to go down like that. Right, so we got a maximum point. Again, we could tell from the graph, because the vertex is up here, the y-intercept is down here, so it has to open down. So it makes sense from our graph that we would get a negative a value, a graph that is opening down. Right, so that ends up being part B. Moving on to part C, we got y equals 4x squared plus 16x plus 2. Let's separate this. So first thing, let's get the y-intercept, just the c value in standard form. So that's going to be 0 and 2. And now let's take this standard form quadratic and let's complete the square on it. So we can first take out a 4. That x squared has to be by itself. Now when we take out a 4 from these two, we divide this by 4, we divide this by 4, so we end up with x squared plus 4x, and then we got a plus 2, like that. Right, and then you could check this part quickly. If you take that 4, redistribute it in the bracket, you should end up with the original two terms, which you do 4x squared plus 16x, and then the plus 2 stays on the end as is. Now what you do is you take the b value in the bracket, not the 16, you take the 4. You take the 4 divided by 2, and then you square it. So that would be 2 to the power 2, which would give us 4 as well. So we'd end up with 4 brackets, 16x plus 4x. What do you do here? You always do plus this value. The plus comes first, and then you do minus that value. And then you got the plus 2 at the end, right? The plus has to come first always, because with a perfect square trinomial, that c value is always positive. The b value here can be positive or negative, but that c value has to be positive for a perfect square trinomial. And then what we do, we take out this negative 4 outside the bracket, but when we take it out, we got to multiply it by what is in front here. So don't forget that step. So we'd end up with negative 16 plus 2, right? Negative 4 times 4 gives us negative 16. And then from here, this is going to be a perfect square trinomial. That would be x plus 2 squared. Negative 16 plus 2 gives us negative 14. So I'm not going through the actual factoring process here. If you want to do it on the side, do decomposition. We've done an entire section dealing with perfect square trinomials. So at this point, I'm assuming that you're fairly comfortable taking something like that and factoring it to that. Okay, so we end up with this right here. So this quadratic, exact same thing, just in different formats. And because we're dealing with a positive a value here, we got positive 4, we know that this quadratic is going to open up, so we're going to be dealing with a minimum point. And the vertex here is going to be negative 2 and negative 14, like that. And it's going to be a minimum point. And we can confirm that it's going to be a minimum point, because if we take this, even just ignoring this positive a value and the fact that we labeled it a minimum, we could tell just by graphing the vertex and the y-intercept. So we got the vertex here, which is at negative 2, negative 14, and then the vertex is at 0 and 2. we can just tell by the way everything has to match up that we're dealing with a quadratic that is opening up, and so we're dealing with a minimum value right there. Okay, so this quadratic ends up being that graph right there. Moving on to part D, we got negative 3x squared plus 36x plus 12. So the y-intercept we can get right away. It's that c value of the standard form, 0 and 12. And then let's take this quadratic that's in standard form and let's convert it to vertex form. So first thing we do, we take out this negative 3. The x squared has to be by itself. 36x divided by negative 3 would give us negative 12x. So that's what we end up with in the bracket. And then we got a plus 12 on the outside right there. And then we take this negative 12, we divide it by 2, and then we square it. So that would be negative 6 to the power 2, which would give us 36. So we take that 36, and then we go plus 36, minus 36. Remember, the positive has to come first. And then we do plus 12, like that. And then what we got to do, we got to take this negative 36 outside of the bracket, but when we do, we got to multiply it by whatever's in front of the bracket. Can't really see that. So taking this out, got to multiply it by that negative 3 that's in front. Negative 36 times negative 3 would give us positive, what, 108? So we end up having a positive 108 now outside of the bracket, plus 12 like that. Then we got negative 3. This is going to be a perfect square trinomial, x minus 6 squared. Right, you could tell sign's the same, and then just half of that value. 108 plus 12 would give us 120. And so we end up with that vertex form. So this quadratic, they're the exact same thing. And now that it's in vertex form, we could get the vertex, which is 6 and 120. And because it is opening down, right, the a value is negative, we know we're dealing with a maximum value. And then we can confirm that on the graph we're going to make. So let's say 6 and 120. That's like over here, approximately. And then we got a y-intercept of 0 and 12, which is going to be right down there. We end up with a quadratic like that, right? So this quadratic, if you graphed it in Desmos, you'd get something that looks like that. And then finally, the last two, so starting with part E, we got y equals negative 9x squared plus 18x plus 2. So from here, we could tell that the y-intercept, the c value, it's going to be 0 and 2. Let's get the vertex, so let's take that quadratic and let's complete the square on this. So we could take out a negative 9 from the first two. X squared minus 18x divided by negative 9 will give us negative 2x. And then we got a plus 2 at the end. Right, again, I always just quickly do a little mental check. If I take that negative 9, bring it back into the bracket, do I end up with those original two expressions? Right? And so you could tell that you do. Then what you do, you take the negative 2, divide that by 2, and then we're going to square that. Negative 2 divided by 2 gives us negative 1 squared. That's going to give us positive 1. So then what we do, we go x squared minus 2x plus 1 minus 1 plus 2, like that. Then we want to take out that negative 1 from the bracket, but we got to multiply it by what's in front of the bracket. We got to multiply it by negative 9. So we'd end up with negative 9x squared minus 2x plus 1. Negative 1 times negative 9 would give us positive 9. Then we got a plus 2 like that. This is always going to be a perfect square trinomial. X minus 1 squared. That's what it factors to. 9 plus 2 would give us 11 like that. Right? So this quadratic, they're the exact same thing. Now, because the a value is negative, we know that this quadratic is opening down, so we're dealing with a max point, and the entire vertex is positive 1 and 11. So if we take this and graph it quickly, we'll have 1, positive 11, so that's like right here, 0 and 2. That's like right here. Let's label these points. And so we end up with a quadratic that looks like that. Okay, and then moving on to the last one. So 5x squared plus 15x minus 11. We can get the y-intercept. That's going to be 0 and negative 11. And then because this is a positive value, we know this quadratic is going to open up. So we know we're going to be dealing with a minimum point. So let's get that vertex value. So we'll have 5x squared plus 15x minus 11. I think we're going to deal with decimals here. So we take out a 5. We end up with x squared plus 3x. Like that. And then we take this 3 divided by 2, which would give us 1.5. Square it, 1.5 squared would give us 2.25. So we end up with 5x squared plus 3x plus 2.25 minus 2.25. And then we'll have a minus 11 at the end there. And then we take out the negative 2.25, same thing, we multiply it by what's in front. We got to multiply it by that 5 right there. And so the next line would end up being 5x squared plus 3x plus 2.25. And then negative 2.25 times 5 would give us negative 11.25. Don't forget this negative 11 over here. And then this here, it's going to be a perfect square trinomial. X plus 1.5 squared, and then this here would end up being negative 22.25, like that, right? So we're dealing with decimals in this particular case, but nevertheless, took this quadratic, converted it to vertex form. We could tell the vertex is this opposite sign, negative 1.5, and negative 22.25, like that. So that ends up being the vertex, and we got the y-intercept, so we can make a fairly accurate graph at this point. So negative 1.5, that's like over here, negative 22.25, that would be like here, negative 1.5, negative 22.25, that's the vertex. Then we got 0, negative 11, that's like right there. And so we end up with a quadratic that looks like that, right? Opening up, and we got a minimum value right there. Okay, so as you get more practice, the process starts becoming a little bit more automatic. Sometimes you'll be dealing with decimals, but the process is still the exact